Okay, yeah, you should do it on
I'll
computer
do
then.
computer.
Yeah.
I'll do computer. Perfect. So I suppose we'll start chronologically, like I said. Um,
This has
you,
started recording.
yeah, yeah.
Okay,
So I think before
cool.
jumping into the technical stuff, I do want to know, I think one of the first things that you told me was you came into Ashoka as a physics major, intended physics major, and you slowly switched toward, not slowly, you switched to mathematics. Um,
Yes.
do you want to talk about why perhaps you were disillusioned, your rigorous math approach, all of that stuff?
I don't know. I mean, I'm still doing physics in some sense. I'm still motivated by questions from physics. So, I definitely do like physics, and the things I'm trying to do are questions that are motivated from physics, but from a mathematical point of view. Why did I switch my major from physics to mathematics? I don't know. It was partly because I could not do physics. I I think I was I don't know. I was seeing I had a fear, a little bit of fear about mathematics. And I was seeing that when I did the same mathematics in physics courses,
Mm-hmm.
um, um, it was very computation heavy, which I don't mind. I mean, I think I'm okay at computation, doing computational things, but you don't have any first principle approach to go back to. And when I learned the same mathematics, so parallelly, I was taking, I think, classical mechanics and MP1, I guess, or
Mm-hmm.
maybe MP1 and linear algebra together. So I was learning linear algebra in MP1, and I was learning linear algebra as a course in mathematics. And I saw that like mathematics gave me a more first principled approach. But then I also kind of stuck to physics. I kept on taking physics courses, one or the other. And so one of the courses that I took was general relativity by Professor Vikram Vyas. I don't know if he's still here.
Mm-hmm.
Uh, and in there, I think I could see that uh, it was one of the physics courses in which like the mathematical training that you acquire. I was taking it in my fourth year, this GR course, was actually coming to be of help. Um, yeah, so just to answer it shortly, I didn't like how mathematics was taught into physics. I don't think I was doing well in physics courses in terms of uh, how I was understanding mathematics. But as I said, I never really switched because I kept on taking courses, theoretical courses, and I'm still doing kind of physics. I mean, I'm doing mathematics, but like the questions are still from physics. Yeah.
Right. So you mentioned that you don't think that you were doing well. By well, do you mean, the traditional grades wise well? Yeah, if in class you weren't understanding the concepts as deeply as you would have liked. Is that what you mean?
Both of them actually. I wasn't doing well grade wise. I mean, I was doing okay. I don't know what like my standards for grade back in first year and my standards for grade right now are very different. So I don't know what good grades are now. But back then it was not a good grade, and back then it was also the case that I wasn't getting much understanding. Um,
Mm-hmm.
yeah. Uh, you see, like they never clarify few of the stuff. So suppose you get stuck on a problem, how do you get back to the first principle approach and try to solve something?
Yeah.
Um, uh, so yeah,
Especially if the problem
that's how.
is mathematical.
Especially if the problem is mathematical. Yeah, I do miss that. I think that if I had done a physics major, I would have a better physical intuition about things, which I really envy about physicists that they have a really good
Yeah.
intuition about things. Uh, and um, yeah, I do find you do acquire a different kind of intuition when you're doing mathematics, but
Have you
uh,
acquired it, or rather, have you like started to develop it?
I mean, I'm just graduated from masters right now, so I've started to develop it. But yes, you do acquire certain kind of mathematical intuitions that what should be happening, and of course, your intuition is very bad. There are trillions of mistakes there, but you do acquire certain kind of different intuition. But suppose you have I don't know, a mathematical axiom while defining some mathematical structure, and you have to motivate it physically. I do find that part sometimes hard to explain, but I think I'm working on it. Hopefully, it gets better.
I mean, out of
Yeah.
curiosity, who does ask you motivate the math from the physics? I don't think that question's coming from the mathematicians. Certain
I don't
mathematicians may
know.
even be more, we can't motivate it through physics, and that's a hallmark of a good mathematical theory. So
No,
it'd be
no, no.
like,
But when you're actually trying to so you're trying to give categorical semantics, you're trying to give semantics to a physical theory. So you have
okay.
certain act, like, oh, I need to motivate them physically also. So that's kind of the examples that I'm talking about. Yeah.
Right, I see. So we'll go into category theory in just a minute, but before that, I have one more question. You said general relativity when you were taking that course with Professor Vikram. You saw that your math training was coming in handy. What did you exactly mean? Were you guys doing more proofs there, or did the rigor help? In what way did it help? Was there a concept in which it helped?
Yeah. Um, the rigor certainly helped. It wasn't a theorem style, like theorem lemma kind of style of course. Of
Mm-hmm.
course, it was a physics course. But the rigor definitely helped. And certain mathematical concepts are fairly abstract and require some amount of time of just, being with it to uh, um, develop an intuition for it. Uh, for example, concepts about dualities uh, uh, are important in general relativity. And I thought like that the physics people who were learning about it for the first time kind of struggled with more than I was struggling with it because I had a mathematical training. So it was
Mm-hmm.
certainly about the more about the rigor um, that kind of helped. And plus, Professor Vikram Vyas was a brilliant teacher, so that also helped. But um, yeah, yeah, it was certainly just the rigor, I believe. Yeah.
Mm-hmm. Interesting. So, did you? So, when I take my physics courses now, so I've done 2 years of 2.5 years of math. And
Yes.
when I sit in my physics courses now, the steps that my professor skips over, perhaps the mathematical steps that he does not, for example, assuming that, differential equation of nth order, some theorem is there,
Hmm.
na? Nth order differential equation has n solutions, or
Hmm.
something like that. And then he just says, "Well, it will have n solutions." I can use my differential
Hmm.
equations course to fill in that assumption, because often in class that would not be stated. It would just be, here's the differential equation. It will of order three. It will have three solutions, and then we proceed to solve it using various methods. And because I've taken my differential equations courses,
Yeah.
my brain automatically fills in, oh, but this comes from this theorem, and thus the picture that I get of the math used in physics is much more complete than,
Yeah.
say, a first year physics major would get from sitting in that same course, because they don't have that mathematical background that I've had. Um,
Yeah.
so on that note, when you sat in your physics courses while you were doing your math degree, did you feel the same way, that you were able to fill in the blanks of, जो professors math पढ़ा रहे थे? Yeah, did that training help in some of your physics courses apart from the generality course, or not really? Like linear
Um,
algebra is used so much in quantum mechanics, and yet you learn very little linear in your mathematical physics one course.
right.
So I
Right.
think that
Yes.
linear would
That's
help significantly in quantum mech.
yeah. Yeah. I, I don't know how to answer this. So my time at Ashoka was very haphazard. So I started as a physics major. So it wasn't that linear algebra was the only course that I was taking parallelly. And then I switched to math major. Then I started doing physics again. And then finally, I think in my fourth semester, I decided, no, I am going to be a math major when you actually have to declare it in OA. And then I only took physics courses later towards the end of my fourth year, my ASPL. Uh, I do like the physical intuition also sometimes. So it's not the case that I was looking for it. It's certainly like I think physicists and mathematicians are also trying to solve different problems.
Mm-hmm.
So Uh, um, for example, like thermodynamics, one of the most beautiful courses I took at Ashoka.
Thermal
I
physics or
didn't mind.
statistical mechanics? Because I don't think we have a thermodynamics course.
No, it was called thermal physics. I
अच्छा
think
ठीक है
it
okay.
was taught by, yeah. Um, so I don't think I mind. I did mind not having a very rigorous approach to it. Uh, that it is based on good physical intuitions. What I don't like, how do I put this? What I don't like is bad physical intuitions and bad mathematical intuitions. So I equally hate that when in maths department people are like, oh no, I don't like physicists' way of doing maths. But like they have been right so many of the times that you need to pay attention that what are they getting their insights out of.
Yeah.
And obviously, like in physics department, they're like, oh, this is purely mathematical. But like, yeah, you do need to not just justify the things that you're doing, but like also sometimes it's not just about justifying that, okay, where does this theorem and uh like comes from, but also thinking about it in a more structured fashion. Um, that if you have certain symmetries, I don't know, I'm just picking a random example,
Mm-hmm.
it will not to look at it like very separately from one another, but to see it as a whole structure and that it does form a group or something like that. Uh, that it also helps you to structure your things, not just, I don't know, fill in the blanks to oh, my prof like the professor missed that. I'm pretty sure like you do feel that way. That
Uh-huh.
there's so many things that you can. It's not about like filling one theorem or filling second theorem or third theorem. It's more like, oh, after I have taken 10 classes, the mathematical content can be organized into 3 pages like this, something like that. Yeah.
Mm-hmm. I think
Yeah.
that came for me when I was so when we were doing differential equations in MP1, and
Mhm.
you're looking at um so when you have what example was I about to give? I'm forgetting this. When you combine linear algebra with right. So you have a differential equation and you change perspectives from differential the calculus thinking to linear algebra style thinking. And by that I mean you think of the dy by dx or d2 by dt squared as a differential operator, and you think of
Mhm.
that thing as acting on a function. So suddenly what
Yeah.
you have here is a linear algebra object, an operator, and over here you have a vector. So naturally you ask, oh well, what is the space of what is this vector space? What are the
Yeah.
functions that sit in it? What are its
Yeah.
dimensions? What are the
Yeah.
eigenvalues of this differential operator? um and
Yes.
naturally you see that okay, eigenvalue मुझे मिल गया, I can find eigenvectors and I can compose them, or linear combinations, I can get a general solution to something like that you can do, which tells you a lot more about the linear operator. So
Yeah.
I think that's what
Yeah.
my math training helped me connect, which was quite
Yeah.
fun. But mhm.
That's really a good example. Yeah, so you don't get a time, you don't get a chance to pay attention to this thing in a physics course that differential thingies are linear. They are a linear operator. I mean, it's obvious when you tell them, but like, yeah, it's not something that we pay attention to in physics courses.
Yeah, and that's extremely fun. Without, if it's not a linear operator, things would be way more complicated. It's because
Yeah,
that it's linear that you have such nice theorems that you can do such neat calculations. Although what?
yeah,
Huh. So I think moving away from Ashoka a bit, you wanted to pursue academia at least, thoda to some extent, masters or PhD. Uh,
yeah.
has that changed the way you laughed?
I don't know if I'll getting if I pursue research is very different from getting a job. But yeah, I just when you were speaking about this, I don't know, that thought ran into my mind. But yeah, I just finished my master's right now.
Uh-huh. And
Sorry, you were saying something. I didn't hear your question. I just a random thought
no,
ran
no,
into
ठीक है,
my
ठीक है,
brain.
ठीक है.
Yeah,
So, you decided to take a gap year and then I think work on category theory. I think under the buy-in, you worked as a teaching assistant, not teaching something. I don't know what it's called. Research
RA,
assistant. Yes.
research assistant. Yeah.
So, do you want to talk about how you found that niche of category theory and quantum foundations? Because no one at Ashoka is really doing much work in that area. And then you found a
Mhm.
CS professor of all professors to grant you an RShip where you were teaching category theory to, I don't know, CS
Yeah.
majors, applied category theory. It's a
I
very
was,
interesting path.
I was. I was always interested in physics, but in particular, I was interested in quantum foundations. Um, I I have a philosophical bent towards things, and I'm not ashamed about it. uh,
It's about to
so,
get hot in here.
sorry.
It's
No,
about to
no,
get
no,
hot.
no.
When people talk about quantum foundations, I have to start with, I'm not ashamed of doing research in this field. But yeah.
Right. I had my gap, like I had my gap years between my high school and my undergrad at Ashoka also. So I did spend some time reading philosophy. In fact, when I started at Ashoka, I was trying to be a physics major and doing some philosophy courses, but that never turned out. But like, yeah, I was interested in quantum foundations. Uh, I I saw that the things were not very crystal clear.
You can go into the
Uh,
specifics if you want, like what exactly you mean,
yeah.
like measurement problem or anything in particular that you have in mind. But
Yeah, I mean, yeah, sure. I will go into this. So many things in quantum are not clear, but when you approach people to it, it's either very dismissive or uh, that they throw so many different things to you that you cannot understand. Like, um, um, I don't know, if you ask a specific kind of a question that what is the state, people can go to, and that's why I don't like the term interpretation. People can go to the multiverse picture. Okay, the state is, it's not, it lives in our universe, it's a multiverse and different sorts of thing. And and your first reaction could be, oh, that makes sense, you know, or you'll be like, oh, that's totally bullshit. But like, yeah, it's either being dismissive or being throwing random information. Um, so I wanted to study quantum foundations by taking, so to say, the mystery out of it by asking precise question and see how it could be answered.
mm-hmm.
I didn't have very specific questions in mind when I was doing my undergrad, but I definitely knew that there was some problem. And just for like my own interest, I would want to solve it. Um, I think back, I was just exploring papers when I was in my fourth year when I came across category theory, and I just started to uh, try to give it a read. I never finished it. So I took a gap year. I definitely saw, I read some parts of the paper, and one of the things was like one of the many confusing things about quantum mechanics is that you have entanglement, right?
Mm-hmm.
And again, when you and nothing to take away from physicists, but I do talk to physics majors. Many of my friends were physics majors because I started as a physics, and I do talk to them about entanglement. And again, it's either being dismissive or being like random information which doesn't relate to entanglement. But I was reading through this paper, and I think I only completed like half of it in my fourth year. And I realized that there was something important that category theory was saying about entanglement. So, and it was fitting with the right taste that it was taking the mystery out of these weird quantum phenomena. So,
Mm-hmm.
entanglement is like the phenomena in which you have um, a state which is not factorizable as product of two states.
Mm-hmm.
So, for example, if your state's like you're working on some Hilbert space, right? Say C2, and your basis is 0 and 1, ket 0 and ket 1 if you want to be fancy, or you can just call it 0 and 1, right? So if you have something like 0, 1 plus 0, 0, then you can factorize it as 0, tensor 0 plus 1, right? But if you have certain state like 0, 1 plus 1, 0, then you cannot factorize it as a product of two states.
Mm-hmm.
Uh, Now, okay, there's a lot of subtlety here, which we'll go into later, but I'm not talking about non-locality. Entanglement is a little bit different from non-locality. I'm just talking about this factorizability problem.
Mm-hmm.
Uh, and it does feel very weird. It does feel very weird. It's like nature somehow having um, combined information of two states without having information about any one of them, right? But people realized that, and by there was this big group at Oxford started by many people. I mean, there were many people, but just like the first form papers was by Abramsky and Kuke, and they realized that the tensor product of Hilbert spaces is not a product in a very categorical sense. So
Mm-hmm.
we people, our mathematical training or our physical training also is very grounded in set theoretic intuitions. So if you have a plane and I give you a 0.32, you will say, oh, what is the 0.32, which projects to three here and two here, right? And I can go three steps in this direction, two steps in this direction, and I get to the 0.32.
Mm-hmm.
What you're thinking about is having a product, right? Uh, but many categories do not have this Cartesian kind of a product. Um and moreover, in category theory, you can make analogies with other categories, which are not so mysterious. For example, the category of sets and relation, where objects are sets and morphisms as relation. And you take the same set X, 0, 1, right? And you make an endo relation on X, right? Which is a subset of X cross X, right? And the relation is it's a subset of X cross X. So I can give you whatever I want.
Mm-hmm.
Empty set is one of them. But I give you the relation 0, 1, 1, 0. Now I cannot write it as a product of any subsets of X, Cartesian product of any subsets of X times another subset of X, right?
Mm-hmm.
So you see that entanglement is not weird. It's not like, how do you put it? Like it's not a bug, it's a feature. By just having your tensor product of Hilbert spaces as not being the categorical product. And I did like that view and I wanted to study it, but I could not sell category theory. So sorry, you were saying
You
something.
could not sell category theory to.
Sell. I could not start to sell category theory. I can't go to anyone in Ashoka and ask for a job in category theory. So I was doing cryptography in my final semester, elliptic curves and cryptography. And I went to the guy and I was like, I want to do cryptography. But he's a very nice person. So he did see me struggling in doing cryptography, and he was like, okay, let's do something you're more comfortable with. What you want to study, and we can see what we can do ahead in that. So that's how I got the time to study like category theory in my gap year.
That's a really nice one to do, actually. Very rare for
Yeah.
someone to do that. On the note of how the category theory viewpoint of entanglement and this weirdness of non-factorizable states, how that got resolved by looking at that problem through the category theory lens. Isn't that sounds like a that sounds like a solution that, to me at least, that would be very appealing to a mathematician more than it would be to a physicist. Although,
Uh,
correct me if I'm wrong, because I don't know much. I don't know anything about category theory or entanglement. But the solution that you proposed, thinking of it from the category theory view, the problem of non-factorizability and how that's a bit spooky. Thinking ki, acha, this has been resolved because the category theory says this. Is that a very mathematical viewpoint to take, or like is that something physicists would agree with, or like what
I
would a
see.
physicist say to you if you said this to a physicist? What would they think?
So I think physicists also know this in some sense. It's just about that category theory makes a very uh, succinct argument for that. So the
Mm-hmm.
weird part about entanglement for physicists has never been about non-factorizability, but about that these states could be well separated in space, right? So there's something non-local going on. But um, so I don't know how like um, um, that would appeal to physicists. You see, whenever you're trying to study a subject, right, there's a lot of formalisms to do it. In one formalism, you can ask many questions, and it almost gives you the language to ask certain kind of questions, right? Think about like, and I think Bob Cook in his paper gives him this example that when
Who gives this example,
quantum
sorry?
mechanics, Bob Cook, he is one of the he was one of the first people to work on this categorical quantum stuff.
Mm-hmm.
Uh, along with his collaborators at Oxford,
Mm-hmm.
I believe at that time. Yeah. Um, so like um, quantum mechanics got in its modern form in 1920s or so, right? The entanglement protocol, not the entanglement protocol, the teleportation protocol, I don't know when it was, at least not till 1980s or even 1990s, right? So it did take a certain amount of time to give you the teleportation protocol, which was always present in quantum theory. Uh, Whereas if you're doing categorical quantum theory, um, it almost is like visible to you once you see the formalism.
The quantum
Uh,
protocol is visible to you. The teleportation protocol is visible to you.
yeah, it's yeah. I mean, if you teach the basics to someone, they can come up with the teleportation protocol themselves.
I
It
see.
is that evident.
Mm-hmm.
Uh, So yeah, it is about I don't know what kind of questions you can ask in certain formalisms, um, what modes of thinking it allows you, uh, and I think definitely category theory is very sellable there. Of course, it does not take out all the mystery away from quantum theory, but and category theory is just one of the aspects in which people are now working quantum foundations, right? There are many different aspects, but we are definitely going into the I believe um, into the time of where we can ask like very precise questions about this uh, um, quantum foundations. For example, you mentioned non-locality, right? Or I think I mentioned non-locality, that
Mm-hmm.
entanglement is not surprising to them. Non-factorizability is not surprising to them. Non-locality is what is surprising to them. And you might have heard like various different things, right? Quantum mechanics is non-local or something like that. But like relativity or like Einstein's relativity tells us that the world is local. So
Do you wanna
what is
tell
going
what local and non-local is once, like colloquially?
So that's what I'm saying. So these are two different. When physicists say, when quantum people say that the world is non-local, they're not meaning that the world is non-local in the sense that it is operationally non-local. Operationally are the things which you can move. Like I have a bottle, I can, apply force to it, see where it lands, or I don't know, I have something which falls. Um, Operational are the things which you can do in a lab, right? Position of things, measurement of things. And which is actually visible to you empirically, right? Ontologically is something which you make a model of, right? Newton can only see the apple falling. Nobody can see gravity, right? So saying that Earth has an attractive pull or something is an ontological commitment, so to say, right? Of course, the ontological commitment has to be good, that it explains the physical stuff in front of you. That's what makes a good scientific theory, right?
So our models are
Uh,
just ontological commitments. That's the fancy word for our models.
our models, yes,
Yeah.
right, exactly,
Whatever we can
exactly.
perceive, you can say that that's our, what did you call that? That's the operational thing, I suppose. Or actually, let's not do
Yeah,
that. And then we model that and we call those models ontological commitments. That we can't see these
yeah.
things, but this is our best bet as to how and why
That's our
this
best bet.
happens the way it happens.
Yeah, and that should explain your theory. That should explain the statistics, so to say, of your
Yeah, the
experiments,
data,
right?
yeah,
The
behavior.
data. Uh, so when physicists say non-local, they mean ontological in a very non-local sense. But even there, things are not very clear. Locality, the term locality itself has a very causal connection to it, you know.
Causal? Oh,
Um,
causal. Okay. What does it mean? Can you locality once? Can you clarify that?
So operational locality, the usual locality means that if you have two parties, Alice and Bob, which are well separated in space, right? Uh, then, I mean, mathematically, it is that the marginals. So, and say Alice can choose. Oops, sorry. And say Alice can choose. Just a second. Say Alice
Mhm.
can choose two measurements, and Bob can choose two different measurements. Uh, um, the locality part is that uh, it does not matter what choice of measurement Bob picks or Alice picks, does not have any effect on the marginals that Alice observes, right? So if you have like measurement A going to, on the Alice side, measurement A going to 1 and B to 0, and on Bob's side, A going to, I don't know, 0, B to 1, the probability that Bob ends up observing for A going to 1 is independent of whether Alice chooses A here or B here or A dash or B dash here. So
Mm.
that's operational non-locality, that you cannot send signals. Uh, uh, you cannot communicate any information uh, faster than the speed of light.
I see. Okay.
Uh,
So it's
that
bounded by the
is,
speed of light.
it is bounded by the speed of light. Yes.
Hmm. So locality
Operation,
simply means, correct me if I'm wrong, you cannot communicate faster than the speed of light. Information cannot travel faster than the speed of light. Okay.
right, right. Yeah, yeah. That's operational non-locality, but like ontological non-locality is different, and we don't know what it means. The point I was trying to say on all of this is that we're now going into like asking very precise question about even these stuff.
Hmm.
That what do
Using the
you
language of
even
category
do?
theory.
Not always. I mean, as I said, category theory. I don't know. I mean, like I'm not an expert in that, but like uh, uh, people, yeah, people have done something around using category theory also to talk about locality or non-locality, but
Okay,
I'm not
okay.
sure how
So basically, we
depth.
have the tools necessary now to ask very specific questions about locality. That's what it. Huh.
Yeah, yeah, or quantum foundations in general,
Hmm.
or quantum foundation in general. So that is something definitely that's out there right now. It's what could be considered as like very philosophical investigation 30 years ago, and now going into very precise uh, domains of mathematics.
Okay, so is this development like how recent is this development? Like when were these tools developed? Did we cross this threshold of, now we can ask precise questions? Because that seems like a very big breakthrough. Because earlier, I think one of the main criticisms of this research in quantum foundations was that this is more on the philosophical side rather than the physical
Yeah.
side. In the sense that even if you get answers to these questions, it's not going to have any major implications for physics. Another criticism was that we do not have the tools necessary right now to probe into these questions, and therefore exploring these questions is just dead end. Now that we do have these tools, I mean, it sounds like a
Mhm.
serious breakthrough. And is that how it's perceived? Ye kab hua? What do you think?
I do not want to sound like an expert because I'm not,
No,
but I don't
no,
know,
हाँ,
like.
but in your opinion, like as much as you know, abhi tak.
Uh, the first thing is that I do empathize with these views that we didn't have tools or something like these are very interpretational or philosophical questions. But I do not see them, first of all, as reasons for not probing them. But the second, but like that's I think besides the point. The second thing that came about was advent of quantum computation and quantum information, right? Uh, Entanglement was once deemed spooky action at a distance, right? Um, but now it's a necessary tool for various protocols. You need entangled qubits to do your teleportation protocol, for example, right? You start with a Bell state, a shared Bell state between Alice and Bob for Alice to transmit some unknown state to Bob. Or you start with some QKD protocols in cryptography, and that requires, again, sharing a Bell state, sharing an entangled state. So suddenly these philosophical bits were now proving to be of as a resource in quantum foundations, right? In quantum computation, uh, and uh, people realize that this is necessary. Also, on the like similar lines, if you take a course in quantum information or if you take a course in quantum computation, you'll be taught like various algorithms, right? Like Shor's algorithm or I don't know, Grover's search algorithm or like I don't remember the name, Bernstein-Swazrani's algorithm and many such, right? And you will see a lot of hype around quantum computation. Um, but the hype is very unfounded in some sense, right? Because uh, all of these classes of problems, except for like the Grover search problem, which is a distinct problem, all of them are same like aspects of like a hidden subgroup problem. So like, can you use quantum computation only to solve two problems in the world? And because source algorithm is one of them, and because our world relies on that cryptographic protocol, it has become important for national security and whatnot. But like, just from a mathematical perspective, what exactly can you do with quantum computation? If it, forget about not having, I don't know, doing ultra cooled atom stuff, and I don't know, cooling your lasers or various different kind of computational models. Um, forget all those challenges. Look 20 years ahead. If you have a quantum computer, what can you do with it? There's not much you can do with it. It can do amazing simulation stuff, but because it is the first print, it was first motivated by uh, uh, um, uh, the to have application in simulating nature. But apart from that, what kind of problems you can solve? So
Simulating what,
entanglement
sorry?
was simulating nature,
Acha, acha, I
because
see, I see. Right.
um, so what kind of problems you can solve? Entanglement turned out to be a necessary resource for one of them. What are the exact class of problems that you can solve with quantum computation? Um, can you do any better? Better in what kind of problems? And understanding these problems won't come from just accidental things where you discover some complexity class versus the other. It'll come from studying quantum foundations. Um, there was a recent paper which says that contextuality, it's a key quantum phenomena. And I think one of the distinguishing phenomena that distinguishes classical from quantum stuff. And in at least in some models, um, and at least like not in qubit mechanics, but like in different dimensions, that turns out to be a necessary resource to move beyond like the stabilizer fragment. So within quantum computation, there's a stabilizer fragment, right?
Uh,
Which is a fragment which you can do on a classical computer very efficiently. So you don't need quantum computers for that. So why invest trillions of dollars into it, right? So how to move beyond this stabilizer fragment towards universality and contextuality in again in some models with some details and some dimensions turns out to be a necessary resource in doing that.
what's
And
contextuality again?
so now we have an understanding that contextuality is a general form of non-locality. Um, uh, Contextuality is the phenomena in which, if I have to put it in one line, in which uh, so if I tell you, if I just throw out the word quantum, right? There are various different words that pops up in someone brains, entanglement, superposition, probabilities. But many of these systems have actually classical analogs. Superposition is not purely quantum phenomena. Um, uh, Even entanglement, for that matter, for the not for the non-locality part, is not purely quantum phenomena. Um, so what is the distinguishing feature? And hints are that contextuality might be the one. And contextuality is the phenomena in which uh, you if you have a joint, if you have various different systems of a subsystem, say, contextuality is a system is said to be like, say, contextual if you're observing something at like the upper scale, at the global scale, and there's no local assignments. Um, um, Sorry, I'm saying it the opposite way around. You're observing something locally in different patches, right? But there's no global consistent assignment that you can come up with that restricts you to give these local assignments that you observed in your patches. Um, um, think about Boolean values satisfaction problem, right? You have different variables, and you assign truth values to it,
Mm-hmm.
right? Or something like these paradoxes, right? Where you have um, the next sentence is true, and below that you write the previous sentence is false, and it's a paradox, right? So locally, there's no problem. If I read the next sentence is false, I have no problem giving the truth assignment to it, right? And if I read the next sentence, I don't have any problem in giving the assignment to it. But I cannot give a consistent assignment to both of
If
these
you read
things.
them, yeah, as a global one
It-
thing, yeah, yeah.
So there's no consistent global assignment which you can give that reduces that. And that's what contextuality is. There's a very beautiful paper which explains contextuality for everyone. It's called Quantum Mysteries Revisited by David Morgan. And it's a very readable paper, in fact, by anyone. Um, so uh, and that turns out to be like necessary for doing some kind of computation. So that's why quantum foundations is also picking up because people are realizing that it is necessary to study deeper problems in quantum computation.
Hmm. Are there
Yeah.
any specific problems? So now that you have, you know, major, in the sense you have done a thesis, a master's thesis, and I think now you've also have a more, richer view of quantum foundations in general. Are there any problems in specific that you're interested in, questions that you're um, keen on finding answers to, or areas that
I have
you? Mm.
I have just written a project proposal, so I must have something. But I don't know. I still want to be very open to what I want to work on. I definitely want to work in quantum foundation. I definitely want to work in contextuality. But within contextuality, what do I want to work on? I'm not very like 100% sure.
Mhm.
Um, yeah, it's a very interesting area, and I think that um, uh, it's a very happening area also that I think it is progressing very fast. So it's a very exciting field to work in. But
Mhm.
what exactly happening, I do not have uh, uh, any clue about this specific question as of now. I mean, I've definitely written something up in the project proposal, but I'm sure that's going to change.
This is your project proposal for what exactly? Your PhD application?
Yeah, yeah, you write project proposals for your PhDs and stuff. So that kind of project proposals, yeah,
Mhm.
exactly.
Out of curiosity, so if there is one question you could like know the answer to, like perhaps in physics, for example, what really is a measurement, or perhaps it's
Mhm.
something a question in contextuality. If there is one like, is there any one question or two questions that you think if we found the answer to that would be a huge breakthrough or would be really important answers to have obtained? Like for you,
Hmm.
what would those questions be? Or what would those answers be that if we got, it would be a huge breakthrough?
Yeah, I'm not sure about breakthroughs, but I mean,
Breakthrough to
research is
you,
all
like what do you think
to
important to you
me.
by your standards?
Yeah. See, the notion of a state itself in quantum mechanics is not very crystal clear.
I
And
just
I
treat
think
it
we
as a
have,
vector in a vector space or something
yeah,
simplistic. It's a very mathematical way to see it, right? It's just a vector in a vector
no,
space at the end.
no, uh, so I just told you about contextuality, right? And it says that you cannot give consistent assignment. So so when you say, okay, I write my state alpha 0 plus beta 1, right? And the probability of measuring in state 0 is alpha squared and 1 is beta squared. Um, when you say probability, what is the first thing you learn about probability? That probabilities are not like out the blue, right? They're over some sample space. They're a distribution over something.
Of
So
course.
what is it over distribution over?
Yeah.
Is it the distribution over 0, 1? No, it's not, because contextuality doesn't say so. That we do not have a consistent assignment to give you in the first place on which you can make your probability distribution. So what is it about? What is it even a probability distribution on? If you somehow know that contextuality says that there's no consistent assignment possible, still, what kind of epistemic things that we can come up with that we still have like a very doable idea of a notion of state. Um, um, Quantum mechanics is also a theory about the world, right? It's not a theory about electromagnetism or gravity or a small world or something. It's a framework of the universe. It's like you give me a state, you give me a transformation, I tell you what happened next. And we do not know what is a state in the first place. So I think that's a pretty embarrassing situation to be in.
Funny state of
And
affairs, pun intended.
so yes. Uh, Uh, that is definitely something I would like a much cleaner answer to.
Hmm.
Um, but yeah, I mean, from doing research in my master's, I realized that um, it's okay to have like big problems in your mind, but then you always go to solve smaller problems. You get into very specific, and then you solve like smaller, smaller, smaller sub problem. until you don't see like why did you even pick this problem to begin with.
The
But
sub
like,
problem or the
yeah,
larger problem?
the sub problem, right? You
Hmm.
don't solve like the big thing by itself, right? You ask a very specific question inside that. Um, so for example, my master thesis was also in quantum foundation and category theory, where we were asking the question that what is the notion of copyability or clonability in arbitrary dimensional quantum mechanics? Uh, uh, so that's one of, again, the separating features between classical and quantum mechanics. So you do attack the quantum foundation from many different directions. What I'm happy about um, is that there's a lot of things that's going on in quantum foundations, which was not the case like a few years earlier.
By few years, do you mean like 10 years or?
Categorical quantum mechanics, if I think it was 2004, so 20 years ago, around 20 years ago.
Ah, so it's pretty
Um,
recent
it is
in
recent.
the scale of things.
Yeah. Understanding of contextuality as a global versus a local thing about not being giving a consistent assignment is even recent. It's like 2011 or something. So
Hmm.
uh, yeah,
Yeah, so
these are
this is
definitely
quite
very,
fresh.
yeah, yeah, yeah,
So you
yeah.
worked in a group where, you know, quantum foundations isn't really a topic that a lot of physicists entertain questions about, especially when
Yeah.
it comes from young researchers.
Yeah.
Um,
I don't think mathematicians also entertain that. It comes from young researchers.
yeah, but
But yeah,
mathematicians don't entertain any physics question. So,
that is true. That is true. Well,
so I mean, the colloquiums are just abysmal. You walk into a colloquium, you're lost after 5 minutes. Like, oh, I don't know who the colloquiums are targeted towards, but yeah,
in math ones or physics ones?
in math ones, at least physics,
Okay.
I can at least sit for 15 minutes and feel be understand something. Math is just there's like a
Right,
huge
right,
hill
right.
you need to climb before you can even understand what the hell's going on.
Yeah, 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 yeah.
So, so as for the foundation, yeah, you were saying.
No, no, no. I was just, yeah,
No, you can
yeah.
deviate. Don't worry. I've
No, no. But I have been to both math. I mean, talks, Ashoka, I have been to, of course, but like conferences, I have mostly been to math conferences. There was one physics single physics conference that I went to, and I think, of course, they're more lavish. Okay, I mean, a bunch of us were going from maths department like, you guys eat this in a conference, not just biscuits and coffee. So that was definitely one of the things. But like, also, I think physicists are kind of very stylish people, they're solving very important problems. Mathematicians, on the other hand, I mean, many mathematicians are full of their egos, but like at least the conferences that I went to are very friendly. But physics ones, because they're solving like the problems of the universe, they will talk over one another. There's a distinct hierarchy between senior people
Oh,
and like not
Jesus.
so people, and they will do jokes at expenses of one another.
But
And
like out of
I
malice or like out of half jokingly, half malice? Yeah, fair.
I don't know, half joking, half malice. Maybe I hope joking was more. But yeah, it's just a different, I think, uh,
Culture.
uh, culture. Yeah, yeah, yeah.
So math people were more friendlier.
To me, I have generally found them. No, I mean the conference that I went to. No, I wouldn't say I do find math people generally more friendlier. But like, yeah, the math conferences, category theory is also a very inclusive disciplines, right? That many people from like LGBTQ community, many people from not many people from global South, but is picking up are doing it. So it's a very inclusive community. So it's a very fair and welcoming thing.
Yeah, I was about to say that it's not like you guys can choose to kick people out. I mean, it
Yeah,
is an upcoming emerging field. It's not like you guys have like
yeah,
just lines of
yeah.
PhD students waited to get into program in category theory. So
I don't
gotta
know.
have to
I
be
don't know.
inclusive.
Uh, I'm not sure. Yeah, I don't know. I mean, no. I mean, of course, it's again like it's also the case that people are less, right? Even at the senior level. So, right,
Ah,
it's like in there are definitely people lining up, but it's like, okay, there's so many few people are doing. Actually, it's not very. I mean, I don't know what's the exact number of people doing category theory or something. Yeah.
I think I'm comparing it to something more mainstream. Um,
Uh-huh. Yeah, yeah. Surely,
because
surely, surely.
category theory departments, I'm assuming would be, sorry, to have a category theorist or someone working in that area in a typical university department, I'm assuming that the chances would be quite low as opposed to
Yes,
some other more mainstream fields. Um,
yes.
but on that note, so you went, were a master student in the math department, on the CS department, okay?
In the math department. Yeah,
Math
yeah.
department. And your advisor was a mathematician by training? Like, what was their training?
I had two advisors. One was the one I mostly worked with, and he was in the CS department. So I used to sit in the CS department. And my other advisor was and he was a mathematician who sits in the CS department. My other advisor was from maths department, and he was a physicist by training. So there was a lot of interdisciplinary kind of thing that was going on. But yeah, I was in the math department, but I mostly worked with this guy who was by training a mathematician, but sits in the CS department. Robin Cockett is his name.
Robin Cockett, right? And how was your like advisor? How did it go?
Oh, yeah, it went really well. I mean, Robin has deeply influenced me, I must say.
Mm-hmm.
He was a very good advisor. Um,
Deeply
he
influenced you in
did,
what sense?
I mean, just in mathematics, just in like, I don't know, getting your shit down, getting to the whiteboard and trying to do mathematics kind
Mm-hmm.
of thing.
Right, right, right.
When you graduate from your undergrad, right, you have a very different idea of research. Then you actually go and do it.
Mm-hmm.
So he made me work hard. He pushed me to my boundaries. It was fun, and he also works a lot with you. He did give me a lot of time. Um, um, it was yeah. Um, um, I think one of my favorite things about him was that like whenever he used to get in the morning, he will just get a good cup of coffee and then uh, he will just see who of his students are available. And it was if it's me in the morning, then I'm the first one to get in under his hood, and he will just start doing mathematics with you. And he will not like sometimes he will meet you in the evening, and he will not stop on the board until it solved the problem. You are tired, you want to go home, you have your dinner to cook, and here is this like 70-year-old guy sitting who is tirelessly working on it with you, and it is quite inspiring. But it is also quite it was also quite tiring at times. But yeah, I mean that was one of my favorite things to do, was to work math with him, do math with him. um uh, yeah.
It sounds like, first of all, it sounds like he was very invested in his students. And
Yes, he
the
was.
fact that you enjoyed doing math with him tells me that you felt comfortable enough to do maths in front of him, like to make mistakes, to present
Yes.
arguments, to ask for feedback without, I suppose, letting your ego come in the way.
Yeah, yeah,
Even
yeah,
when he would point out mistakes or would criticize,
yeah,
which I think, I don't know how common that is to find, let alone in a person, sorry, in a person, let alone in someone who's in a profession like academia and math, where people see this as smart लोगों का profession and बहुत ego भी होता है.
yeah.
So yeah,
Uh, I used to think, but because in research mathematics, it's often the case that you are talking between two people, right, who are
Mhm.
trying to come up with a new thing. So both of them are, maybe I'm more likely to make mistakes. Um, than he is, but he will also make mistakes in his things. And I think someone at the level of Robin, I think he usually, I mean, I could still not gather it. He was also British, so he was also very humorous, right? So he would just come up with theorems. He would be walking into my office and he'd be like, can you try proving this? I think this is true. Okay. And it's spent like a week, not a week, maybe less than that if it's not that big of a theorem, proving it. And it requires like pages of calculations, not calculation, but like diagram chasing or something like that to go on. And he would just conjure up with these theorems. But while actually going to the board and doing this calculation, he would make like the silliest of mistakes. So it's like uh, it, it's like I don't know. Both of these abilities go uh, hand in hand. So it's like um, um, uh, while collaborating, I often felt that he had this humility that he made you feel um, equal, that you can work with him and collaborate with him. But while it is specific to your project or you're doing something wrong, and he also had this supervisor thing that when you're going in the wrong direction, he would like, of course, do course correction for you. So yeah, it was a good mixed bag.
Hmm. I think you said
Yeah.
you told me that having a good advisor is probably one of the most influential
Yes.
things that in your math journey. Um,
I think in yeah, I think sometimes I think about in graduate school, I think it's the only thing that matters. Uh, uh, Also, in terms of just like practicalities, where you'll end up after your master's, where you'll go for a PhD or a postdoc if you're doing a PhD and all of these things. The most important factor is your supervisor. Of course, you should be interested in the problems that you're working in, because most of the times you'll be doing it alone, not with your supervisor. But like if your supervisor is interested in you, the speed of things gets fairly quickened up,
hmm
so to say. And you can do much more if you find a supervisor who is invested in you
hmm
rather than one who, yeah.
hmm Do you feel like your peers also found those kind of supervisors, or or was it like you were one of the lucky ones who were able to find such a mentor?
I think I have, I, I think I'm, yeah, I think I have been lucky. I think there are definitely people like that. I think I've been very lucky in terms of people I have come across in academia. My supervisor and my co-supervisor also, Carlo Maria Scandolo, who was a physicist by training. I also didn't work very exclusively with him, but this contextuality series I actually presented to him because I wanted his feedback because he
hmm
has a physics training. Then the people that I collaborated with uh, uh, are uh, or the people that I do talk to are very kind and generous people, and they're very secure people, first of all, to begin with. Uh, so I have been definitely lucky. Uh, from what I've heard, that this species is rare in academia, and I've definitely seen the other side,
In
that people who
conferences,
are
at conferences.
at conferences, in my own, I don't know, explorations of people
Uh,
sometimes, of course, big names, but like, yeah, there are definitely people full in academia of ego, but like somehow I have been very lucky in getting such people, yeah.
hmm Any masaledar stories from the conferences? Just to spice things up a bit that you may want to share.
Not masala. I don't know. I think we were talking the other day, right? I think मतलब मैं तो भाई मास्टर्स कर रहा हूँ ठीक ना. इसके बाद पीएचडी मिले ना मिले, उसके बाद पोस्ट डॉक मिले ना मिले, उसके बाद प्रोफेसरशिप. It's a never endless journey. But like even at this early stage, and maybe because of that early stage, I could
Uh,
not. I somehow never understand that where this ego comes from in academia. You're so you're so मतलब आपको पैसे इतने कम मिलते हैं. Okay. You don't have a stable life. You are moving from continent to continent until you settle down to a professorship. Okay. Four people are reading your paper in your own field. Where is this ego coming from? The people who are doing like so far more important things in the world, and they often don't have that ego. So where is that ego coming from? So I don't know. I've been told so many different things, especially as I said, when you're a young researcher, that you're like you're trying to do category theory because you are trying to be a philosopher. You don't have mathematical
I
abilities.
think I
Quantum
know you
foundation,
told me who said that to you, but no names.
okay.
Yeah.
Quantum foundation is a philosophical discipline. There's no mathematics in it and all those things. And it's so surprising to me because so many accomplished people are doing quantum foundation. I mean, this guy I was mentioning, Samson Abramsky, is FRS, and he was one of course, with Bob Cooke, one of the first people to notice that. He also worked in contextuality kind of
Mm-hmm.
thing. And I'm not, I don't know. You are forcing me to come up with a metric, right? Your H index is 5. Someone else's H index is 80. You are saying that person is wasting their life upon something like I never understand where these things come from. Like your area is the most important area,
Yeah.
and the thing that you are doing, yeah, I think you do get egoish people everywhere, but maybe the percentage is a bit on the higher side in academia, definitely.
Mm-hmm.
Um, yeah. Part of it is just because how competitive it is, academia. So, and a bit elitist also. So I think part of that is just that. But part of that has to do with something like personal level. I don't know. Yeah.
Yeah. I think it's also because of the perception of math and physics, and I think these so-called
Yeah.
hard sciences. I mean, the fact that we
Yeah.
call them
Yeah.
hard in the first place. Like whenever
Yeah.
I'm sure this would you would relate to this experience, but when I tell people that I'm majoring in math and computer science, apparently that makes me smart, or apparently they perceive me as, oh, this person is very smart, very intelligent,
Except for your
and
friends.
yeah,
Except for your friends.
yeah. And then I talk to them and they realize, oh, that's not necessarily true. So
Yeah.
So
Yeah.
I think the perception
Yeah.
of the field matter a lot because I remember I never really had an ego about whether I'm doing math or physics or I'm doing something like psychology. I find all fields are equal, are really interesting, and they explore important questions and important कौन decide करता है क्या important है नहीं. But I remember after 2 years of my math degree, I did feel like I did get that. मेरे अंदर भी वो घुस गया था कि यार if I walk into a biology class, the math of it or like the technical aspects of it should come easier to me. And
Mm.
so I think arrogance would be too strong of a word, but I think मुझ में भी वो seed like घुस गया था that, if I walk into a social science class, not social science, if I walk into a biology class, if I walk into, let's say, chemistry class, if I walk into even a computer science class, then I should
Mhm.
be faster than the computer science students simply because I've done math courses which are apparently harder. And this is not a way
Mhm.
of thinking. This is not how I ever thought about um,
Mhm.
learning. Yo, this is
Yeah.
harder. This is better. This is um, you know harder. So I think that entire culture उसकी वजह से भी बहुत elitism आ जाता है because
Yeah.
तुम research कर रहे हो math है जैसे field में, and
Yeah.
like you said, it's so competitive.
Yeah.
So yeah, there's also this thing about accessibility. Like, we're talking in English right now. You look at the papers, all
Yes.
of them are in English.
Yes.
Where do you publish these papers? Well, you give them to give submit them at journals, which have like huge paywalls. So then there's this another
Mm.
question of, who gets to access this knowledge. Um, like, even if you can't afford it, then to bhul jao if you're not a big university. If you're not fluent in English,
Yeah.
too bad. Um,
Yeah. When I said elitist, I just didn't mean like mathematical or science. I think academia in general is very elitist,
mhm.
just by the nature of it. Um, I mean, government institutions certainly helped, and strong government institutions in India certainly helped, right? You had institutions like IITs and JNU, but sadly they are now crumbling down. So that makes
JNU especially, जब से दिल्ली
bigger
में.
access. Yeah, JNU, they have done crazy shit to JNU, but like yeah, um, accessibility is um, um, definitely a problem. I think the difference between India and outside country is that because India is such an unequal country to begin with, right? There's so much inequality in India to begin with. Like the first thing you notice when you go to the West is how equal West is.
Mhm.
Of course, there's poverty
Relatively.
there, there are rich people, but like relatively, it's so equal. And in countries like India, when you I don't know butcher up government institutions, I mean, Ashoka is a great place, right? But it is at the end of the day a private university, and a
Yes.
private university, no matter how generous you are, no matter how right your intents are, you simply do not have that penetration as a government in university, like a JNU would. So yeah, that's certainly something to be worried about. Um, you have US, which has like good universities, which are private universities. You have Canada, where good universities are actually government universities. But the thing about US is that, well, um, uh, it is a relatively equal society to begin with. So you can have institutions that thrive there, but not like you cannot have uh, um, you cannot go away from the model of strong government institutions in India.
You can't rely on them, you're saying.
No, I mean that's the way to go. I'm saying the way to go is strong government institutions in India and make government institutions stronger rather than trying to butcher them. Of course, like there are clear motives on why the government institutions, especially something like JNU, is getting butchered, but uh, uh, and it'll have like serious repercussions. But from my understanding, that uh, um, I mean, if access to knowledge is only limited to a certain thing, after a point, what are all we even doing, right? So it's um, um, you cannot survive. I don't think you can survive on the model of uh, private institutions. Like you cannot think that you will have an MIT and a Harvard and a Stanford in India, and you will get rid of all government institutions. That
Yeah,
cannot simply happen in
yeah,
India.
yeah.
Um, yeah.
Although the efforts, I think privatization is extremely scary because I think you come from the east. I'm not sure
Yeah.
how government hospitals are in the east, but I think Kerala में तो they're really bad.
Kerala, mein, it's bad. I
नहीं नहीं
see.
मैं ईस्ट से बात कर रहा हूँ. I think you're from बिहार.
I'm from Bihar. Yeah, yeah,
हाँ,
yeah.
so वहाँ पर गवर्नमेंट हॉस्पिटल्स कैसे हैं?
Very bad. I mean, you go there to die. You can't go there to survive. So, uh,
Right.
uh, yeah.
Yeah, so my point is just Kerala में of course it's known for to have such great facilities and all. Um,
Hmm.
so it's really scary to see something as fundamental as, एक तो हॉस्पिटल्स एंड एजुकेशन बिकम प्राइवेटाइज. हॉस्पिटल्स तो खैर बन
Uh-huh.
ही चुके हैं, पर अगर
Yeah.
एजुकेशन भी बन जाए बिकॉज अशोका इज नॉट द फर्स्ट प्राइवेट यूनिवर्सिटी. अभी और भी यूनिवर्सिटी स्प्रिंग अप हो रहे हैं. आई थिंक वन स्कैरी थिंग दैट आई फाइंड इज दैट a lot of, I think, British, Australian, and American universities are like creating satellite campuses in India. So now I can get, did I lag out again? I think I lagged out again. कितनी भी प्राइवेट यूनिवर्सिटी बना लो, ये वाईफाई ठीक नहीं करने वाले. थर्ड ईयर आ चुका है, अभी भी ठीक नहीं करा इन्होंने. एनीवेज,
अशोका वाईफाई का क्या प्रॉब्लम है मुझे भी नहीं पता यार.
I think students keep on increasing. No, I don't know what it is. How is the Wi-Fi this bad for being this much?
Yeah.
But anyways, I was just
But
huh.
one thing to clarify on the last point was that, like, I'm not saying that private universities should not be there. Ashoka is, in fact, Ashoka is one of the good ones, right? Where the main motive is education and not just like printing money, unlike some of the other ones. So, and they have such a good, rigorous curriculum and everything and good professors. But like, I'm saying that it just, I mean, it can be an addition, but it cannot be a substitution for strong government institutions in India. Um, definitely.
Yeah.
Yeah.
Especially I think on the more academia side of it, I think India is a bit different. I don't know how common publish or perish culture is in India. Did you experience publish and perish? Like, could you or did you see other people having experiencing that?
I'm a master's student, Vedant. I'm already
Huh?
perished. What do you mean publish or perish? I have a I'm a master's I just finished my master's. What do you mean I'm publish or perish? I don't know. I don't even know about these things as of now.
No, you must have heard of it, no? Publish or perish. As in, either you do make publications and you get some research
Right.
output, like a minimum number of
Mm.
papers a year. Otherwise,
Yeah.
you're just not going to have a career. And the idea is basically the thesis that, researchers these days have to negotiate between pushing out papers, pumping out papers, churning out papers, and having an academic career, and then
Mm.
balancing that with research quality. In the sense, you may not want to work on this research problem because you know कि यार इसका paper शायद 5 साल में निकलेगा. But if I work on these
Mm.
other research problems which aren't as important, but if I work on them, I can churn out like 5 papers this year itself
Right,
in
right,
top
right.
quality journals, even though the research may not be, even though the question is not that important. So I think that's the
Yeah.
thesis of publish and perish. But did you see that in action during your time, master's
I've
के
heard
दौरान?
about it. I've heard about it definitely. And there's of course like from very even an early stage, there's pressure to publish. Um, but I don't know how bad or how strong it is. Um, I've seen people like trying hard to publish, and I've seen people that worried about not making certain amount of publications before applying for a certain postdoc or a faculty position. But I don't know. Um, Nobody asked me to publish in my master's, so I at least I'm at a too junior stage to feel that pressure. Yeah.
It's good then. I think you've had a good experience, at least academic wise, in your master's.
Yeah, yeah, yeah. I mean, we are publishing, but like, I won't say it is there was a pressure to do it.
Mm-hmm. Apart
Yeah.
from that, were there any like hard times during your master's? Because you moved from India to Canada.
Mhm.
देश चला गया, climate भी I'm assuming काफी different होगा. And like
Yeah,
you said, master's का schedule is quite rigorous because you're doing research for the first time as well in a new country.
yeah.
So I'm assuming that it's not like you can travel back home every 3 months when you're feeling homesick, no?
No, no, no. Yeah. And Canada is also very far, so that adds. Yeah. Um, there was, uh, yeah,
Balancing all of that and being an adult for the first time. Like I think at Ashoka as well, it's a bit you're not a fully an adult, you're like a semi-adult because
yes,
college में रह रहे हो, residence में ही रह रहे हो, you're still living with your friends. But there, though, you're
yeah,
managing expenses, cooking your own meals.
yes,
So
yes,
it must have been a
yeah.
big shift.
It it was a big shift. The biggest shift was the distance I'd say from home. Like even if you want to, you go and check the flight prices and you know that you cannot come back home. So the biggest thing
How
was
much was a
the
ticket, average price, like groupie में?
मतलब डिपेंड भी करता है ना कि when are you getting the break. So when are you getting the break? It's the time when everyone else is getting the break. So that's when it's the most expensive.
So
You
how much
cannot.
could it go up to
Oh, there's no limit to how much you can go up to. But like
on average
think
for you?
about like it's like spending around minimum 1.5 lakh uh, in a to and fro journey. If you don't cost like local जब आप आओ तो वहां पे जो खर्चे होंगे hotels के जो खर्चे होंगे and all those things. But
हाँ
minimum 1.5 lakh you can go up anywhere. Yeah, yeah.
हाँ, one more for like both ways, no? Like not.
Yeah, yeah, both,
हाँ, sugar है,
both
okay.
ways, both ways. Yeah, yeah, both ways. But I'm saying that's on the minimum end. That's like, I don't know, the time like February or March when no one is going and coming in. But like if you talk about December or something like, or
Oh
May,
jeez.
then it's like 2, 3 lakhs. Yes.
Oh भाई साहब.
Yeah. Uh, yeah, I won't say it was very difficult in those terms in cooking for myself. I was being an RA in Ashoka, so I
Oh.
was habituated to, but not that frequently, like as I did in Canada. Um, because master is also a very short degree, so you're
Hmm.
mostly focused on your research. So your mood also depends on whether did you get some results this week or not. How did the result go? If it went well, you're going to cook like something very like biryani, like a meal on Sunday, and if not, you're just going to make dal chawal for the rest of the week. So it's like it's mostly like that.
What is this hate
I'm
towards dal chawal, yaar? I like dal chawal.
no hate towards dal chawal. I I'm from Bihar, so we don't eat dal chawal, सिर्फ दाल चावल. बहुत सारे लोगों को मैंने देखा है. So I need some sabji or something with it.
अच्छा, ओके,
But you was
ओके.
dal chawal.
You all a bit fancy in Bihar.
Ah, yeah. We are a bit
दाल
fancy in
चावल से काम नहीं
Bihar.
चला, सर को सब्जी भी चाहिए.
Uh, I was lucky enough to meet good people, so it was smoother because of them. Um, uh, and yeah,
Okay.
it wasn't. Yeah, I had a group of Bengali friends who were doing a postdocs there,
Oh
and they
गॉड,
were
वहां भी बंगाली है? अच्छा.
everywhere. Bengali in academia is everywhere. But we had a good time. I mean, we used to cook like every second month or so a big pot of meal, and I don't know if I can say this, but buy a large pack of whiskey and then finish it throughout the day and something. And then there was also someone, Professor Rintu, actually introduced me from here. So she was there along with her family.
A
So
professor
it was some,
introduced you to someone.
yeah. So I think Rintu Senior was not think Rintu Senior is a postdoc in Calgary. Um,
That's their
and she's
name.
now
Prof- prof-
Ankita. Uh,
Hmm.
um, So she was settled there with her family. So I had a good time with her family. Also, at times we used to try to get together like once every couple of months. So it does get easier when you get like your own people around it, but the distance certainly is, uh, yeah, it does get to you if you want, if you let it get to you. So what I did was like I would go office 6 days a week, not 5 days a week. Because if I'm here on the seventh day of the week, then I know that I have my grocery to do, I have my laundry to do, and I have my food to make. And that will take most of the day. But if you're 2 days of the week, you get one day free. And then what will you do? What will you do in like minus 35 degrees?
Oh God. Minus
Play.
35.
Minus 25 is for a week or two, but like the standard temperature is like minus 15, minus 20, which is
That's
also bad.
insane.
Yeah. So what will you do? So yeah, I don't have much complaints about my time in Calgary. I think it went fairly well, except for like sometimes I was just like distance was something that was worrying, but that's it.
Jesus. Okay. Apart from
Yeah.
that, what are your future like tentative plans? PhD in what? In where? Under who? Do you know?
No, I mean, these things you cannot say until it's confirmed.
Oh,
So
of course,
uh,
tentative. तभी तो बोल, I love that word.
no, 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 no. Even tentative is like it's like you want to do it, but then it didn't work out, and then because of some stupid reason, and then yeah. But I mean, for the area, definitely I want to continue in quantum foundation. I want to stick to category theory, but also like see other avenues of research in quantum foundations.
Hmm.
Uh, and I want to do it with the right people, of course. Uh,
What does that mean? Like
uh,
people who are like right people.
People who are doing it. I mean, people who are working in that area, exact area. I have been talking to them, so let's see what works out and what does not work out.
Mm-hmm.
Uh, I want to do a PhD, but at the same time, I also want to pick some like other skills. Mathematics makes you very unemployed, and I am
Okay.
worried about that.
Good to know.
Hi, you are doing some computer science also. Think about me. I never did a computer science course, so
Look, answer, tell me this honestly. I feel like
mm,
after doing something as math is hard. It's not like an easy field. You have to go back after every lecture and go through it, right? It's not like
yeah,
you can just go through 4 lectures and then अच्छा आज पढ़ने बैठते हैं. नहीं भाई, हर lecture में पढ़ना होता है तुमको. So
right.
given that a degree is rigorous and you do learn some hard stuff, I'm thinking that how hard can it be to pick up like computational skills? Like is it that difficult or is it because structure नहीं होता? You have to do it on your own, so friction ज़्यादा आता है उस वहाँ से.
Mhm. No, no, it's not. It's not difficult, but like, yeah. I think it just like you have some, I don't know, some unsaid friction about these things, and I have not been as disciplined about picking some computational skills as I should have been. And lately, I've been realizing that I might actually end up being unemployed after my if I don't do that. So, and that is something I cannot afford. So I definitely want to go pick some computational skills during my PhD.
Mm-hmm.
Uh, uh,
Cool.
that's the plan. I don't know what will happen after that.
Mm-hmm.
Yeah.
One final question that I forgot to ask when we were discussing quantum stuff. I think your advisor, or I don't know who said this, but it stuck with me the first time we were talking back last year when I think I took your number from Preetham. That
Mhm.
someone said that, we will spend time work. So they were talking about quantum foundations, and they said something like along the lines of, we have been working in this field for 20 years so that your generation does not feel ashamed to work in quantum foundations. I think you said
Yes.
that someone said that to you. Do you want to
Yeah.
explain
Yes.
who
Yes.
and the story behind that?
No, I mean, quantum foundations was not a very hot area, right? Uh, and again, I don't know. I feel like I don't want to be a patron of this area or something like that. So I'm not answering it like that. But just from an objective point of view, also, uh, it was not a very so to say a respected area in physics or mathematics, but lately it is becoming so, and so many people have worked throughout when it was not very respectable, when it was not very employable. I'm not sure how employable it is now, but it was not very respectable right then. And there have been many people who have worked tirelessly during this time, and that should be like yeah, and that's what I'm saying. I feel like I'm living in a very exciting time in respect to this area, that the path is much more clearer for someone who is interested in quantum foundation right now than say 30 years ago.
Mm-hmm.
That's definitely the case.
Mm-hmm.
Yeah.
That's nice to hear that fields are actually, not treated as, oh, this is not respectable. Um,
Yeah. 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 Yeah.
I had no idea how much ego academia has, like the whole respect thing. I literally just thought
Have
if you're
you
curious about it, you explore it. Like very naive view of how research is done. But
have you come across egoistic people in academia?
my peers, and I'm not saying
Oh,
all
really?
of them, but even some of them.
Yeah.
But I suppose peers may you could feel be discount. You could say कि हाँ, they're young, of course, they're arrogant. But
Mm.
I think I get hints of arrogance from professors or colloquiums sometimes. But
Yeah.
I've noticed like, a lot of anxiety amongst students of not
Mm.
being smart enough, not getting things as fast in class as others, not getting a
Yeah.
grade as high as your peers, and then feeling like you're not cut out for the field. Like I've certainly felt that throughout my math degree.
Yeah.
And it's been like it takes. I'm still on the journey of explaining to myself that an exam or a 3 month course alongside other courses college के अंदर where you're managing other things as well, it's a very limited way to test your capability and potential as a researcher, and not just a researcher but also an explorer in general. um
Yeah.
so
I don't think it tests research skills at all, first of all. It
Mhm.
tests the
Comprehension perhaps of the material.
course. Yeah. So sorry, go ahead. I was just interjecting there.
No, no, ठीक है, you can interrupt and all, but it takes a lot of effort, or it has rather, from my side, it explained to myself that my taking in 3 months taking 5 courses, juggling that with relationships, juggling that with being in college where there's so many things are going around, um,
Yeah.
and not getting a good grade is not necessarily reflective of my ability. It just means that in that moment in time, in that situation, at that point in my life, I didn't know how to answer that question. That doesn't mean I can't learn that topic later, at my own
Yeah.
pace, when I'm more comfortable, when other things are more
Mm.
settled. So
Mhm.
I've seen this anxiety among students a lot, where they will fight tooth and nail to get that extra grade, and that at least
Yeah.
अशोका में मैंने बहुत देखा ही है.
अशोका में है,
तो
हमें ज्यादा भी है,
कुछ ज्यादा ही मैंने
बट
देखा है यहाँ पर. सो
अशोका में ग्रेड्स का थोड़ा yeah, it's very yeah. But that's definitely there. But I think, with time, as you are now in your third year, right? When you go to your fourth year and your later, you see that you start finding your own niche. There was one person in your class who was the fastest, but you were the most, I don't know, sincere when it come to a certain area. And that's kind of becomes nicher and nicher until you make a craft for yourself. And it is a long process, but that it does eventually uh, 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 happen. And I think research is a great window to that because you're no longer solving a problem that could be solved in a class or something. It has to be solved in a much longer span of time. Uh, and It's more about just throwing your hands out
Hmm.
there. That would happen
Yeah.
or and some tests or something. But yes, I mean, I think I definitely felt that when I was an undergrad about my peers and stuff. But when you look back, it's definitely the case that everyone has carved out their own niche and it's no longer. I mean, PhD में जाके भाई तुम किससे compete करोगे? तुम्हारे बगल में जो बंदा बैठता है, that's doing totally different to what you are doing. You're no longer comparable at all. So, and people will come up with random metrics, all sort of thing. But all I'm saying is, at least in this aspect, it is not comparable.
Yeah. Yeah. I think research is also different in the sense that perhaps your motivations are also different in research. In a course, perhaps your motivations are I want to get the good grade because I want to feel smart, and I want to project to my professor and my peers that I'm smart. But research, mein the so I'm rambling here. The research question doesn't care what your training is, whether you're a mathematician or you're a physicist or
Exactly,
you did
exactly,
philosophy.
exactly.
It
This
doesn't
is
care whether
exactly.
you got a A in linear algebra or not.
Yeah, yeah, yeah.
If you can
Exactly,
solve it,
exactly.
you can solve it. If you can't, try
Oh,
something else. It
you
doesn't
tried
care about
something,
your
it
GPA.
worked. Go back and look the definition. It worked. Oh, it didn't work. It didn't work. Doesn't
Yeah.
matter what
It doesn't
what
care about
field
your
it is.
GPA. It doesn't care about your credentials or your Nature publications or your Age Index or all the Nobel Prizes that you won. If you can't
Yeah,
solve it, you can't do it. The end.
yeah, yeah,
So I think that's also something that I find quite amusing that you can bring like the most top-notch mathematician and physicist like Fields medal वगैरह सब कुछ जीता हुआ है. Give them a problem. नहीं हुआ तो नहीं हुआ. That's the nature of the
yeah.
field.
That's it. That's it. That's it. Yeah,
Doesn't
yeah,
care about your credentials.
yeah, yeah,
So
yeah.
that's an amusing thing. But I suppose, in the interest of time, I suppose that is it for this conversation. Um,
Nice.
this was fun. I haven't done
This was
this
fun.
in a month. I think you'll have to stop recording, or do I?
Okay. Uh,
Or does it tell me to record? Oh, okay.
how do I?
मिल गया मुझको मिल गया